Okay, students. So, in the previous chapter, we did an activity. We looked at the different types of chemical reactions. What are they? Chemical combination reaction. You have two or more reactants forming one product. Then, the example was magnesium burnt in air. So, their magnesium and oxygen are the reactants. They give rise to magnesium oxide. Then we looked at the second type, chemical decomposition reaction. When you have potassium permanganate, when you heat it, potassium permanganate decomposes to produce potassium manganate, manganese dioxide, evolving oxygen gas. Then the third type you all remember, magnesium reacting with dilute sulfuric acid or zinc granules reacting with copper sulfate. So that is the single displacement reaction. Then we had the last type. We looked at the last type, double displacement reaction. Sodium sulfate and barium chloride. Two colorless solutions, when you mix them together, barium sulfate forms a precipitate and sodium chloride is the colorless product. So there it is a double displacement reaction. So you are familiar with the four types: chemical combination, chemical decomposition, single displacement and double displacement. So in this chapter, I will be discussing each type of reaction individually with more examples. The first one, chemical combination reactions. Consider the first reaction of the activity. In it, magnesium reacts with oxygen in the air, forming magnesium oxide. So, I just mentioned that to you all. If we write the reaction, magnesium plus oxygen giving rise to magnesium oxide. So, in a reaction, students, you all know on the left hand side, we have the reactant. So, magnesium and oxygen are the reactants. Arrow shows how the reaction takes place, the change takes place, and on the right hand side, we have the product, one or more products. So, there it is magnesium oxide. And I told you all this is the word equation. For the same word equation, I can write the balanced chemical equation. So, here it is magnesium plus oxygen giving rise to magnesium oxide. So, when we balance the reaction, we needed to have 2 in front of magnesium and magnesium oxide. I will explain how we do that when we discuss balancing chemical equations. So, 2 magnesium reacts with oxygen forming 2 magnesium oxide. So, the 2 reactants and the product. In this, here 2 elements have combined to form a new compound. Magnesium is an element, oxygen is an element, and that is a compound. So, 2 or more substances, 2 or more elements combine and form a new product. That is the chemical combination reaction. Chemical combination reaction. So, if we look at the explanation, the formation of a new compound by the combination of elements with elements or elements with compounds or compounds with compounds is known as a chemical combination reaction. So, 2 elements can combine like this, magnesium and oxygen. Then you can have an element combining with a compound, again forming only one product. Or else we can have 2 compounds combining and forming a product. Those are all different types of chemical combination reactions. Now we will look at some more examples under chemical combination reactions. A few other examples for chemical combinations are given below. Carbon, oxygen giving rise to carbon dioxide. What type is that? Both carbon and oxygen, both are elements. Elements combine and form the product. So, as I told you all before, students, we can write the balanced chemical equation as well. Carbon is denoted by C, oxygen, CO2 gas because it's present as oxygen gas, diatomic molecules, O2 in atmosphere. That gives rise to carbon dioxide. Two elements combine and form one product. Carbon plus oxygen, carbon dioxide. The same way, if we take carbon dioxide and carbon, their carbon dioxide is a compound and carbon is an element. A compound and an element react to form carbon monoxide. So here students, you all can see carbon dioxide is a compound, carbon is an element. So a compound and an element combine to form the new product, carbon monoxide. Then we have calcium oxide and water. What is calcium oxide? CaO, calcium oxide. And water is H2O. So when you write these, you all have to remember the chemical formulae of compounds, or else you are familiar with writing chemical formulae. So if you know calcium oxide, calcium is Ca, oxygen, you need to exchange the valencies and write the formula. So calcium oxide and water giving rise to calcium hydroxide, CaOH twice. So here again, two compounds combine and form one product. Then the last type, hydrogen chlorine, H2 and Cl2. Both are elements. Both of them exist as diatomic gases. Diatomic molecules, they are diatomic molecules, exist in the form of gases, H2 gas and chlorine gas. When they combine, they form HCl, hydrogen chloride. Here students, you all have to remember something. Now as a note, you all need to remember. Now when we have hydrogen chloride, HCl, in the gas form, we call it hydrogen chloride. But if you have HCl in the form of solution, say the hydrogen chloride gas dissolves in water and you get the HCl solution. How do we call that? That is hydrochloric acid. This is hydrochloric acid. So HCl gas is hydrogen chloride. HCl solution, or in the liquid form, it is hydrochloric acid. So that is why you have the same chemical formula. I am sure you all can remember and understand that now. So then, if I go back, here you all can see students, both are elements, compound and element, compound and compound, again two elements. So we said in the previous explanation when we discussed chemical combination reaction, two elements or an element with a compound and compounds can combine and form one product. Is that clear to you? So from all these examples, I am sure you all can understand what chemical combinations are. Remember, two or more reactants have to be there. Only one product has to be there. So with this, we can write a common formula. Common chemical or common equation for chemical combination. reaction can be written as A plus B giving rise to C. So, one reactant, the other reactant giving rise to one product. Chemical combination reaction. Is that clear, students? So, the first type of reactions, chemical combination. With that, I will move on to the next slide. Chemical decomposition reactions. So, again, you are familiar with this reaction. Reflect on the second reaction in the activity. What is that? In that reaction, potassium permanganate decomposes under the influence of heat to form other compounds and elements. So, when we did the reaction, students, you all were able to observe a black color solid remains when you heat potassium permanganate. And I mentioned to you all, potassium manganate and manganese dioxide are the solid substances. At the same time, what did we do? We used a glowing splint in order to identify the liberation of oxygen gas. So, there are three products: potassium manganate, manganese dioxide and oxygen gas. So, when potassium permanganate decomposes, potassium permanganate on heating decomposes and forms potassium manganate, manganese dioxide and oxygen. So, if we write the equation, potassium permanganate is KMnO4. It is the purple color crystalline solid. When you heat, for heat, students, we use this symbol delta or a triangle. You can see this refers to heat. So, potassium permanganate gives rise to K2MnO4 is potassium manganate. K2MnO4, MnO2 and oxygen gas. K2MnO4 is potassium manganate, MnO2 is manganese dioxide and O2 is oxygen gas. Here again, students, you will learn how to balance the equations. For now, I will balance it. So, here you can see there are two potassium atoms, 2 Mn, 2 Mn, there are also 2 Mn, then oxygen 2 into 4, 8. So, there are again on that side also 8 oxygen atoms. But don't worry about the balancing now because we will be discussing that under balancing chemical equations. So, this is the balanced chemical equation. 2 potassium permanganate on heating decomposes to form 1 potassium manganate, 1 manganese dioxide and 1 oxygen. So, one reactant gives rise to 3 products. And in the products, you can see here, students, these are compounds. And O2 is an element. Compounds and an element are produced. So, if we look at a chemical decomposition reaction, the decomposition of a compound giving other simpler compounds or elements or compounds and elements is known as a chemical decomposition reaction. So, it can give rise to simpler compounds only or simpler elements or both elements and compounds. So, this type is the third one, compounds and elements. You have 2 compounds and 1 element produced there. So, from this, if we try to write a common equation, A will become B plus C. There is one reactant, it will be a compound that will decompose to form two or more products. And those two or more products can be elements, compounds, or compounds and elements. So usually we might need to heat it. And this symbol is for heat. Is that clear to you all? Chemical decomposition reaction. So now that you know what chemical decomposition reaction is, we will discuss some more examples. Okay, students. So now I am going to do this activity again to observe another chemical decomposition reaction. We already observed one reaction, that is the decomposition of potassium permanganate. On heating, potassium permanganate decomposes to produce potassium manganate, manganese dioxide and releases oxygen. So here I am going to do another reaction, that is with hydrogen peroxide. So here you can see, students, it is hydrogen peroxide. Usually at room temperature also hydrogen peroxide can decompose slowly. So to prevent that only, we store that in brown colored glass bottles so that the sunlight does not penetrate in and the reaction can be prolonged or prevented. So now what I am going to do is, I am going to take a small amount of hydrogen peroxide into the boiling tube. We will need to heat hydrogen peroxide. So here I am going to take a small amount of hydrogen peroxide. Then we need to heat it. So I am going to heat this hydrogen peroxide. You all have to observe clearly, students, what happens there on heating. You all have to observe. Can you all see the formation of gas bubbles at the bottom? They are from the bottom, you all can see, students. Now when we heat, can you see the gas bubbles evolving? So here you all can see, students, the evolving of the gas bubbles. That is oxygen gas. So on heating, hydrogen peroxide decomposes. It undergoes chemical decomposition, giving rise to water and oxygen gas. So that is the chemical decomposition of hydrogen peroxide. You all can see the gas bubbles there. This is another reaction, students, a chemical decomposition reaction. Hydrogen peroxide H2O2 on heating gives rise to H2O, water, and O2, oxygen gas. So another example of chemical decomposition. Some examples for chemical decomposition reactions are given below. So first one, calcium carbonate. You can see the symbol heat, giving rise to calcium oxide and carbon dioxide. So here calcium carbonate on heating gives rise to calcium oxide and carbon dioxide. Now one compound, that is the reactant, decomposes to produce two new compounds. Calcium oxide, carbon dioxide, both are compounds. Then the next one, hydrogen peroxide gives rise to water and oxygen on heating. Hydrogen peroxide is written as H2O2. Water is H2O, hydrogen peroxide is H2O2. When H2O2 is heated, you will get H2O, that is water, plus O2. So here, of course, we will need to balance it by adding 2 in front of H2O2 and 2 in front of H2O. So hydrogen peroxide gives rise to water and oxygen. So a compound as the reactant. What are the products? Again a compound and an element. Water is a compound, oxygen is an element. Then we have the last one. Silver oxide on heating gives rise to silver and oxygen. Silver oxide Ag2O. Silver is Ag argentum, you all can remember, has valency 1. So oxygen valency 2, you get the formula as Ag2O. On heating, it gives rise to silver plus O2 gas, oxygen gas. So in order to balance, we need to have it like that. 2Ag2O gives rise to 4Ag plus oxygen. So silver oxide is a compound, that is the reactant. On decomposing, it produces 2 elements. Silver is a metal, it's an element, and oxygen is the gas, non-metal, it's also an element. So now we have seen 3 different types of chemical decomposition reaction. Why? Depending on the products. Both are compounds, compound and element, both are elements. All these are chemical decomposition reactions. I am sure you all can understand that clearly. So with that, we will move on to the next type of reaction. What is it? Single displacement reaction. Single displacement reactions. So single displacement reaction, focus your attention on the third reaction of the activity. In that reaction, zinc metal reacts with copper sulfate, freeing copper metal and forming zinc sulfate. So those are the reactants and products. Zinc plus copper sulfate, giving rise to zinc sulfate plus copper. Or you can write it as copper plus zinc sulfate. So here zinc plus copper sulfate gives rise to copper plus zinc sulfate. So this is a balanced chemical equation. Zinc is an element, copper sulfate is a compound, gives rise to copper, again an element, and the compound zinc sulfate. So here you can see zinc displaces copper. It frees copper from the compound. So that is why we call it as single displacement reaction. The reactions in which an element displaces another element in a compound, occupying its place and forming another compound are referred to as a single displacement reaction. So their element, that is zinc, displaces another element, that is copper, in a compound. The compound is copper sulfate, occupying its place. So when copper is displaced and zinc occupies its space, you get zinc sulfate and forming another compound. Is that clear to you all? So zinc displaces copper, occupies its space and forms the new compound zinc sulfate. So that is single displacement. So if we are to write the common reaction for single displacement, A plus BC giving rise to AC plus B. That is the common reaction. You have an element, you have a compound, will give rise to another compound and one element will be displaced. Single displacement reaction. So now we will look at some more examples. Okay, students. So now we are going to look at a few single displacement reactions. So you all know in a single displacement reaction there are two reactants. One is an element, the other one is a compound. And the element displaces another element from the compound. And finally in the products also you get a compound as well as an element. It can be a gas that is evolved or it can be a precipitate. So we will observe few reactions like that. To do this activity, I have copper sulfate solution, magnesium strips and hydrochloric acid solution. So first what I will do is I will take a small amount of copper sulfate into a test tube. So here you all can see clearly, students, you are familiar with this solution, the light blue color solution of copper sulfate. Then I have the clean strips of magnesium. Here I have already, you all are familiar with that. Normally the oxide layer covers the magnesium strip. I have cleaned it now. So I have a few pieces of clean magnesium strips. So I'll be using that for the activity. For the first one, what I will do is into this copper sulfate solution, I will put a clean magnesium strip. We will observe what happens there. So when I put that, can you all see the liberation of hydrogen gas there? Students, can you all see the reaction taking place? There, copper sulfate reacts with magnesium strip. So that is how you can observe the reaction. And you can see some solids going down and depositing at the bottom. So that is the reaction between magnesium and copper sulfate. You can see the reaction taking place. What I will do is, I will keep this aside. I will do the second reaction and again, finally, we will observe what happens when the reaction completes. So here, you can see clearly, students, the reaction taking place between magnesium and copper sulfate. You can clearly see the changes taking place. So I will keep this aside and then we'll do the second part of the activity. Here I'll take a small amount of hydrochloric acid solution into this test tube, HCl solution. And into that also I will put a piece of clean magnesium strip. So here again you can see the reaction. This is the evolving of hydrogen gas. You can see the liberation of a gas there. Can you all see it clearly? You can see the reaction between magnesium and HCl and you can see the liberation of a gas. Evolving of a gas or liberation of a gas. You can see that clearly. Can you all see that clearly, students? Here, if you look closely, you can see the liberation of gas. So that is the hydrogen gas. So again, if we leave this for some time, you can see the complete reaction would have taken place. So I will keep it on the stand. We will observe the previous reaction again. As I told you, students, I kept the two reaction mixtures. One is the copper sulfate and magnesium. The other one hydrochloric acid and magnesium. So now I'll show you all the observation. Can you all see here, students? Can you all see the color clearly? At the bottom, you all can see the brownish color precipitate. What is that? That is copper. So when we put magnesium into copper sulfate, magnesium displaces copper. So that is why the color of the solution also has decreased. The intensity of the color is less now. That is because copper has been displaced from the compound copper sulfate. So the reaction between copper sulfate and magnesium is a single displacement reaction. Why? Magnesium displaces copper. So I am sure you all can observe the changes clearly. The same way I told you all, now in this also, now you all can see at the top you can see a very tiny piece of magnesium. I put a small piece of magnesium into hydrochloric acid. You were able to observe the liberation of hydrogen gas and still the magnesium is reacting. So there magnesium plus hydrochloric acid. Those are the reactants. Magnesium displaces hydrogen. That is why hydrogen gas is evolved. And in the solution, it will be magnesium chloride that remains. So this is also a single displacement reaction. Magnesium with hydrochloric acid giving rise to magnesium chloride and evolving of hydrogen gas. So when the reaction completes, it will be only magnesium chloride solution. Unless there is excess of hydrochloric acid, there will be magnesium chloride in the reaction, the test tube, and also the hydrogen gas has already evolved from the test tube. So both these are examples of single displacement reaction. So before that, students, I showed you all the reaction between zinc and copper sulfate. That is also a single displacement reaction. So we have observed 3 types of single displacement reactions. Given below are some examples for single displacement reactions. So here if we look at the single displacement reactions, first one, magnesium copper sulfate giving rise to magnesium sulfate and copper. So magnesium is Mg, copper sulfate is CuSO4. Those are the reactants. Reactants are separated by the plus, giving rise to magnesium sulfate and copper. So here you can see, students, magnesium is an element, copper sulfate is the compound. Magnesium displaces copper and forms a new compound by occupying the place of copper. That is why we get magnesium sulfate. Is that clear to you? So magnesium copper sulfate giving rise to magnesium sulfate and copper. Then we have the next one, magnesium plus hydrogen chloride giving rise to magnesium chloride and hydrogen gas. So magnesium plus hydrogen chloride giving rise to magnesium chloride is MgCl2, because the valency of magnesium is 2, chlorine is 1. So MgCl2 plus hydrogen is H2 gas. So in order to balance it, we need to put a 2 there. Magnesium, hydrogen chloride, that is HCl in the gaseous state. 2HCl gives rise to MgCl2, that is magnesium chloride, and H2 hydrogen gas. Here, students, you all have to remember all these examples. You should know to write the chemical equation, and that also has to be balanced chemical equations. That's the second one. The third one, we have potassium bromide and chlorine giving rise to potassium chloride and bromine. So KBr is potassium bromide and chlorine is Cl2 gas, gives rise to potassium chloride KCl and bromine Br2. So here of course we will need to balance it. 2 KBr plus Cl2 gives rise to 2 KCl plus Br2. So those are some examples for single displacement reactions. I have shown you all this before also. If we are to write the common reaction for the single displacement reaction, how did we do it? AB plus C gives rise to AC plus B. So here you have a compound, you have an element. This element displaces the other element, B, from the compound, occupying its space and forming a new product. So that is the single displacement reaction. I am sure you all can understand this type of reactions and you will remember the examples. You will be able to write them correctly as well. So with that, we will move on to the next type of reaction, that is double displacement reaction. So when we say double displacement reaction, consider the reaction 4 of the activity. You can remember that. In that reaction, barium chloride and sodium sulfate react, giving barium sulfate and sodium chloride. So, how do we get that? Barium chloride plus sodium sulfate normally students we write the chemical equation in one line, but here I don't have enough space, so I'm writing it in two lines. But these are the reactants and after the arrow it is the products. So we will get barium sulfate and sodium chloride. Barium chloride and sodium sulfate react to form barium sulfate and sodium chloride. So, barium chloride is BaCl2 plus sodium sulfate is Na2SO4 giving rise to barium sulfate BaSO4 plus sodium chloride NaCl. We will need to have 2 NaCl. So, barium chloride plus sodium sulfate giving rise to barium sulfate and sodium chloride. So, here of course students, you all can see barium combines with sulfate, chlorine combines with sodium. So, both the components are displaced. That is why we call it double displacement reaction. Barium sulfate here and sodium chloride there. Double displacement reaction. In this, both the reactants have to be compounds. Then only double displacement will take place. So, here we can see a reaction in which an element or a radical contained in a compound is exchanged with an element or a radical in another compound is called the double displacement reaction. So, here students, you all have to remember element, you all know barium, sodium, those are elements. Elements, barium, sodium, those are elements. And when we say radicals, you're familiar with this. We have discussed polyatomic ions or molecule ions, radicals. You all can remember when we discuss chemical formula. They have a charge. A molecule that has a charge is known as a molecular ion or polyatomic ion or a radical. So, here what are the radicals? Sulfate is a radical. SO4 2 minus. Barium, sodium and even chlorine, those are elements. Although we have chloride ion, but it is an element, ion of an element. So, barium, sodium and chlorine, all those are ions of elements. But sulfate is a radical. So, a reaction in which an element or a radical contained in a compound. So, in this there are two elements. In sodium sulfate there is an element and a radical is exchanged with an element or a radical in another compound is called the double displacement reaction. So, in one barium chloride we have both elements. In sodium sulfate one is an element, the other one is a radical. So, they are exchanged. Then we call it a double displacement reaction. So, if we write the common formula, common equation, So, if we are to write the common equation, students, we have two compounds AB and CD. So, then there is a double displacement. So what will happen? A is the cation and D is the anion. So the cation has to combine with the anion only. Therefore, A will combine with D. At the same time, C is the cation, B is the anion there. You all know that, students, normally when we write chemical formulae, we write the cation first or the positive ion first. So there, of course, this will become CB. So AB and CD are the reactants. When they combine, they will form AD and CB. That is how the double displacement reaction takes place. So like in the previous one, if I show the combination, here you can see B and C combine, A and D combine. So they displace each other, but both displacements take place. Therefore, we call it as double displacement reaction. I am sure you all can understand that. So with that, I will move on to the next slide where we will look at some more examples. A few other examples for double displacement reactions. Double displacement. Ferrous sulfate. Now when we say ferrous, you are familiar with these Latin terms for different elements. Ferrum is iron. Ferrum is iron. So when you have Fe2 plus ions, we call it ferrous sulfate. So ferrous sulfate is FeSO4. Why Fe2 plus, valency 2 plus 2. So sulfate is 2 minus. Therefore, it is ferrous sulfate is FeSO4. And sodium hydroxide, NaOH. So when we look at the equation, they give rise to ferrous hydroxide, FeOH twice. You know that because this has 2 plus, OH has minus, so 1 valency, it's FeOH twice. And sodium sulfate, Na2SO4. So here again, both are compounds. In this, Fe and Na, they are elements, and SO4 2 minus and OH minus, they are radicals. So now you all can understand how double displacement takes place between elements and radicals of compounds. So their elements or radicals are exchanged with either elements or radicals. Double displacement. Then we have another example. Calcium chloride and sodium carbonate. Calcium chloride, CaCl2 plus sodium carbonate, Na2CO3, giving rise to calcium carbonate plus sodium chloride. So here CaCl2 is calcium chloride. Both are elements, ions of elements. Again, sodium, ion of an element, but carbonate is a radical. Then calcium carbonate and sodium chloride. Is that clear to you? Ferrous sulfate and sodium hydroxide giving rise to ferrous hydroxide and sodium sulfate. So the next one, calcium chloride and sodium carbonate giving rise to calcium carbonate and sodium chloride. So if we write the common equation. So here, students, if we write the common equation AB, why it is a compound, and we have another compound CD, and when that gets exchanged, A and D plus CB. So as I told you all before, A is the cation here. So combines with the anion of the second reactant, AD. And whereas B is the anion here, C is the cation here. So it has to become CB. So that is the common chemical equation for a double displacement reaction. So students, these are the Some more examples of double displacement reactions. Ferrous sulfate reacting with sodium hydroxide giving rise to ferrous hydroxide and sodium sulfate. There also the reaction needs to be balanced. So 2 there. FeSO4 plus 2 NaOH will give rise to FeOH twice and sodium sulfate Na2SO4. The same way, calcium chloride reacts with sodium carbonate, giving rise to calcium carbonate and 2 sodium chloride. And the common equation is given by AB plus CD, giving rise to AD and CB. So that is the double displacement reaction. Okay, students. So those are the 4 different types of chemical reactions. The chemical combination reaction, chemical decomposition reaction, single displacement reaction and the double displacement reaction. I am sure now you all have a very good understanding about the 4 types of reactions. If you are given a reaction, you will be able to identify what type of reaction that is, and also you will need to remember all these examples. You should know to write the word equation as well as the balanced chemical equation. So with that, students, I will end this chapter, and in the next chapter I will discuss how we can balance chemical equation.